So we are going to do notes on page 9. We're going to do what's called a mean absolute deviation. And this is something you're going to see several times over the next couple of years. And it probably is going to take a little while for you to completely understand it. So this is kind of just our first time looking at it. So just do the best that you can. If you have questions, please ask me. This will be important, especially like if you're in business, because this data, it's a lot of business statistics, things like that. And so this will come in handy of kind of having this knowledge. So a mean absolute deviation is a measure that gives the average distance of each data value to the mean. Okay, so we're going to take a look at these and we're going to look at the steps. So, and I'm going to use this data set that is up here. So I'm using this pink and I'm going to do the steps with it. So to find the mean, I'm going to do 2 plus 4 plus 6 plus 7 plus 8 plus 15. And I'm going to divide that by 1, 2, 3, 4, 5, 6. Okay. So I'm going to add all those up. So pick up your calculator and add those together and tell me what you get. Or tell the screen what you get. Okay. So when you add those together, I got 42. So check my math. And there's 6 things, and 42 divided by 6 is 7. So the mean is 7. And this is, you're finding the mean on this. Okay. So what you're going to do next is you're going to take each value. Okay. And I'm just going to kind of use colors so you can see this. You're going to take the 2 and you're going to figure out its distance, which means it doesn't really matter if it's positive or negative. So you're going to do 2 minus 7, but that's why it's called an absolute, is it doesn't matter the sign. You're going to just do the distance. So I just need you to look at the distance. So the distance from 2 to 7 is 5. Okay. And then we're going to look at 4. Okay. And again, I'm going to use some colors. What's the distance from 7 to 4? It's 3. It doesn't matter positive or negative. You're just looking at the positive. Then you're going to take a look at the next one in the data set. It's 6. How far is 6 from 7? It's 1. And then you're going to look at the next one, and it's 7, and the mean is 7, so the distance is 0. You do need to write it down because you're going to see why in a second. And then you're going to look at the next one, and it's 8, and the distance is 1. Okay, just like the distance from 6 is 1. I don't really care if it's above it or below it right now. I just want to know how far away it is. Okay, so don't worry about above or below. And then the last one is 15. How far away is 15? 15 minus 7 is 8. So these are how far away. And then what you're going to do is you're going to take those numbers, 5 plus 3 plus 1 plus 0 plus 1 plus 8, and you're going to divide by how many? You're going to find the average of those numbers. So 5 plus 3 is 8. 8 plus 1 is 9. 10, that's 18. 18 divided by 3 is 6. So that means the average distance from the mean to the data is 3. Now, and so you're wondering, well, how does this come in handy like in business and those kinds of things? So what you would do is you would have, like, if you were selling something, you would have a great number of data values, and all of a sudden, like, they're all in one area, let's say like 20,000. Let's say you had a bunch of stores and everybody was selling about 20,000 a day. And then all of a sudden, this one store sells 500. Okay, that makes you aware, wait a minute, that's way off what it should be. Like, they are all around 20,000, this is way off. So then you would take a look, okay, what's going on? Did the store burn down? Somebody stealing from you? Like, there's a million things like it. So that's why you kind of have to have an understanding of what it means. No one's going to ask you as an adult, find me the mean absolute deviation. No one cares. But if you understand what it means, then it helps you be more knowledgeable about situations. Okay, so if you use this, we're going to kind of just take a look at this really quick. Okay, so if I look at this first data set, the first thing you do is you find, so step 1 is to find the average. So you take the numbers, so 2 plus 4 plus 6 plus 15 plus 18, and then you're going to divide by 5. So take a second for me and add that up and divide by 5. I think you get 45 when you add it up. Divided by 5 is 9. So the mean is 9, right? Okay, and then step 2, I'm going to put step 2 and 3 together if it's okay with you. So I'm going to, because all I did up here is I wrote them in this list and then I went ahead and added them. So I'm going to put them into the addition problem. So how far away is 2 from 9? It is 7 away. How far away is 4 from 9? It is 5. How far is 6? Is 3. Oops, I'm not going to do commas. I'm just going to add them. How far away is 15? Is what? 6. And 18 is 9. So I'm going to take those and add them together and divide by 5. So when I add that up, 12, 30, wait, 12, 21, 30. Yeah, I was right. 30 divided by 6 is 5. So the mean average deviation is 5. So the middle is 9, but they're on the average, most of them are at least 5 away. Okay, so now I'm going to do the next one. So I'm going to do the average. So 6 plus 7 plus 9 plus 10 plus 13. And I'm going to divide by 5. Okay, and so I add those up. 13, 22, 32, 45 again. So my average is 9 again. So the average is 9. Now, how far away are each of the data points for 9? So I'm going to do steps 2 and 3 together, and I'm just going to write them as addition. 9 and 6 are 3 away. 7 and 9 are 2 away. 9 and 9, 0. That's a 1, and that's a 4. So 5 and 5, so that's 10 divided by 5. So these ones, this 2 means that it's a lot closer. Like your data points are closer together. Okay, it's not so spread out. 5 is pretty spread out. So then if I look at the next one, 9 plus 9 plus 9 plus 9 plus 9 divided by 5. That's 45 divided by 5. My mean is 9. Okay, how far away are all of them? All of them are at 9. So your mean average deviation is 0. So your MAD is 0. So what does that mean? Okay, that means the closer the mean average deviation is to 0, the less variation there is in the data. Okay. What do outliers do? Like if I look up here, this 18 in the first one, that yellow 8, that's definitely an outlier. Like that's way up there. Okay, probably even the 2 is probably an outlier on the other end, right? So what do they do to this MAD number? Oh my gosh, I did this. Have you been yelling at me this whole time? Because there's 5 data points and you're dividing, so this is 6. Sorry. It makes it, what does that do? It makes it bigger. Okay, if you have outliers, your MAD value is going to be bigger, okay, because the data is more spread out. All right, so let's take a look at one more of these. The high temperature for the last 5 days is given there. So I'm going to take 90 plus 81 plus 85 plus 92 plus 82. And I'm going to divide that by 5. So when I add all of that up, I got 430 divided by 5. And you can check it for me, but I think that I did it right. And so my mean is 86. So this is my mean. Okay, so now I'm going to take a look at each number. How far away is 90? It's 4 away. How far is 81? It's 5 away. How far is 85? It's 1 away. 92 is 6 away. And 82 is 4 away. So I'm going to do those. That's 10, and 10 is 20 divided by 5. So my mean average deviation is 4. Okay. All right. What I would like you to do right now, I would like you, because I think that you've kind of got this. So I'm just going to have you do, I would like you to do 2, 3, and I would like you to do one more. I'm going to kind of zoom out so you can kind of see it. I would like you to do 6. I would like you to pause the video, and I would like you, I would like you to do 6 because it has decimals. And so I just want to make sure you're okay with decimals. So pause the video and do those 3, please. All right, these are ones I'm just going to write answers. Hopefully you paused. Hopefully you're done, because just writing down an answer, if you don't know what you're doing, that could be in trouble. So if you get these wrong, please text me. The mean average deviation is 7 on number 2. The mean deviation on number 13 is 17, or number 3, sorry, is 17.2. I'm okay with the decimal. So you can leave it as a decimal. And then the last one, the mean average deviation is 2 point, nope, I was on the wrong one, 0.88. Okay, so these also can have decimals.